Okay, ladies and gentlemen, my question now to you becomes, if I want to find a factor, or whether a factor is actually a factor of a larger polynomial, how do we do that? Well, the first and easiest way to do it is to use the remainder theorem. Now, folks, if I had something as follows, 6, 1, 3, and I wanted to determine, is that divisible by 7? The very first thing I would do is I'd say, well, 7 goes into 6 no times. So then I'm going to say, well, 7 goes into 61. 7 goes into 61 about 8 times. So 8 times 7 is 56. So I do a little subtraction, and I come up with 5. But then, of course, I can't leave it there, so I bring down a 3. When I bring down 3, I say 7 goes into 53. It goes 7 times. And I say 7 times 7. 7 times 7 is 49. And then I again switch that sign and subtract, come up with 4, and we say, oh, that's not good. Because at this point, I can either say 87 point and set up a 0 and bring it down. I could say 87 and 4/7. Or what I could say, and this is where we're going here, is 87 R4 for remainder of 4. Now, if I have a remainder, it means it does not go in evenly. So the basis of the remainder theorem is that if something is divisible by something else, then your remainder will be indeed 0. So, given that little fact and this method, let's do long division for polynomials. Something you did in Algebra 1, you've done it in Algebra 2, you are expected to know it here. With that, we have 6x cubed minus 25x squared plus 18x plus 9. And I want to determine, is x minus 3 a factor? Well, just like I said, 7 goes into 6. Nope. 7 goes into 61. Yeah. In this case, I'm going to say x. X goes into 6x cubed. Well, it's going to need another x squared to make it go. And it's going to need at least a 6. So 6x squared times x, just like 8 times 7. And in this case, 6x cubed. Well, that's very nice, except that I also have a minus 3 component. So I give it away to minus 3. And I come up with negative 18x squared. With that, I now do just as I did over here. Instead of positive 56, we said subtract. Well, it's a better way to think of it is switch the signs. But if I'm going to subtract the whole thing, I'm not just going to switch one side. I have to switch both signs. So that's gone. And this makes negative 7x squared. All right, just like this, I had a 5 left over, and I brought the 3 down. I'm going to bring down the plus 18x. And we're going to say, all right, how many times does x go into 7x squared? It's going to go in negative 7x times. We're going to multiply. Negative 7x squared plus 21x. And again, just like we did with the 49, we're going to switch those signs. And by switching those signs, those go away. And we're left with negative 3x plus 9. Well, how do I change an x into a negative 3x? Well, it's going to need a negative 3. Negative 3 times x gives me negative 3x plus 9. Then I need to go through and switch the signs. Gone, gone, remainder of 0. Now, if there wasn't a remainder of 0, I'd say plus whatever this is over x minus 3. But since the remainder is 0, I don't even need it. What I can now say is that 6x cubed minus 25x squared plus 18x plus 9 is equal to x minus 3 times 6x squared minus 7x minus 3. Now this becomes very important because I don't know how to factor a whole lot of cubes. But what I can do is if I can find a single factor, then I can break that down into a square. And once I have everything in terms of x squared, I have a quadratic equation, which means I can use a quadratic formula, and I can keep breaking this thing down as far as it goes using A, B, C, 6, -7, -3, and keep filling these blanks of what it is and break it all the way down to find all my potential solutions. So if I want to know is something a factor, I can divide it by that thing and determine if I have a remainder of 0 if it's a factor. Now, that's all well and dandy, but the thing is, if that is a factor, that means it's also a 0. So what would x minus 3 be as an actual solution? Well, that's the same thing as saying x equals 3. Well, okay. So let's take 6x cubed minus 25x squared plus 18x plus 9. But now I want to know, is x equals 3 a 0? Rather than going through long division, let's use what we have. It's called the remainder theorem. And what we're going to do is, if this is indeed a 0, then if I put it in, everywhere I see x, that means by the time I get it all worked out, if it is truly a factor or a solution or a 0, that means my remainder or the answer here should equal 0. So let's see if it's true or not. Well, that's going to be 6 times 27 minus 25 times 9 plus 18 times 3, so that's 30, 54, plus 9. This is going to turn into 225, negatively speaking, plus 54 plus 9. 6 times 27, well, 27 and 6, I got 2, I got 4. I have 16, 162, if I'm not mistaken. And by the time I start putting all this stuff together, just to double check my math here, okay, so we have 162 minus 225 plus 54 plus 9. If I put all that together, it comes up to be 0. And so it does indeed equal 0. And so this is a factor. Well, you say, well, we already knew that. You did the division. But the thing is, if you prefer not to do the division, you can simply plug it in and determine whether it's a remainder, has a remainder or not. The advantage of doing long division is that once you have the long division done, you now have the broken up piece that I can take that piece and continue on. If all I do is figure out, is it a 0, yes or no, I could guess all day long. And even if I get one of them correctly, what do I have left doesn't help me find any of the additional options. So, with that, we have the remainder theorem. Another variation on the same theme is a variableless division. Now you say, oh, that's synthetic division. Not necessarily. This is doing the exact same thing as we did up here, except you're simply not doing it with variables. You know that as long as this x is to 1, 1x, that you're in essence going to take whatever this is and you're going to guaranteed multiply by it. So if I say 6 times this, well, it's going to cancel out every single time. So we're not going to even put it there. What we're going to do is just worry about the part that's not going to go away. And that is 6 times -3 is -18. But again, just like last time, you're going to have to switch the sign. You come up with -7. Well, again, the -7 is going to go away when I put a -7x here. Alright, so we say -7, and -7 times -3 is +21, but of course I must switch the sign. -3, and that brings down a 9, And in this case, we already know that that's going to be a negative 3 because it's going to have to go away. This times this is 9. Switch the sign, you get 0. So plus 0 over x minus 3. Don't even need that. And you're left with this. Now, the nice thing is, I guess, you don't have the variables to mess with. But the whole time I did this process, I have the variables in my head. It's just they're not on the paper. And really, folks, I don't want to encourage you to use less work. I'd rather encourage you to use more. Besides, this process only works when x is to the first power. And it assumes that you have all pieces here, third squared x number. And that you know that when you're done with a cube that you're going to end up with an x squared. And that you're going to end up with an x and a number. So it assumes that you know this process really, really well. Pardon my French, but I do not assume that of you folks. So there is yet another way we could go about it. This method that we're going to do is very similar to synthetic division, but it's not synthetic division. It's called collapsing vertically. It's simply taking this method here and scrunching it all up. So you say, bring down the 6. 6 times negative 3 is negative 18. And you switch the sign, and you come up with negative 7. Then you multiply this again, and you get 21. But then you have to switch the sign. You come up with negative 3. You multiply again, you come up with 9, but you switch the sign, and you get 0, and that works. That's all well and dandy too, but that requires you to know this method, and you need to know that that's required basically from this method. All fine news. Why don't we just do synthetic division? The only change we have to make with synthetic division is you take the coefficients directly out of the problem. Do remember to leave any zeros for any spaces you don't have. And instead of a factor of negative 3, let's just go straight to the solution, which was, if the factor is x minus 3, that means x equals 3. So, bring down 6 in old synthetic division fashion, 18. This way you don't even need to switch the signs, you just put them together. You get negative 7, multiply again, negative 21, negative 3, negative 9, and you get 0. Now you still need to know that if this was cubed, that this is going to be squared, x, and number. But you'll notice there's no remembering to switch signs, there's no remembering any other process. If you know this process, it's very, very quick, and again, the whole key is if you end with a 0 at the end, remainder of 0, it is a factor. With all those fancy ways to divide and to attempt to find factors, why in the world would you ever want to use long division? Well, because all those tricks only work if you have x plus or minus some number. It does not work if you have 2x something, or heaven forbid you have 2x squared and you want to divide. In that case, long division is your only option. Now, if I'm wanting to divide something, but I do have x to the power of 1, and I want to convert it to something I could use for synthetic division, all I really need to do is factor out a 3. If I take a 3 out of 3x, I'm left with x. If I take a 3 out of 4, I'm left with 4/3. And so now I could do synthetic division using negative 4/3. Now you say, ugh, I don't know that I'd like to do that. Well, you could do this, you could do this. Take your pick. I'm just giving you an option. But if you have anything besides a power of 1, you have to do long division. Okay, just a few problems for homework for you. Page 115, all those numbers, and all synthetic substitution is using synthetic to division to determine if a particular option is a factor. So synthetic substitution, synthetic division, one is the name of the process, one is the process itself. So don't get confused by the change in terminology. But by the way, it's also in your book.